Alright, for this video we're going to look at taking a rational function like the one described here, f of x, and then finding the domain, x-intercepts, and vertical asymptotes. The key to doing this is you have to factor because this is the type of rational function, if you try and put it in your graphing calculator, you're not going to see any of these without knowing where to zoom in. So let's have a look. You got a factor. So if we look at the numerator here, so the numerator is this. So it has degree 3, and the first thing I look for, is there any common factor that I can factor out? And there's not. So when it has degree 3, I can look at the graph of this and see if I can find any x-intercepts, because those will be zeros, and then that's how I'll factor it. So let's put x cubed plus 2x squared. This is an older model one, TI-84 plus. And just make sure that I entered it properly. I did, and I'm going to do a zoom 6. Okay, there appears to be x-intercepts at negative 1, 2, 3, 4, 5, 6, negative 7, at positive 2 and positive 3. So I can use negative 7, 2, or 3 with synthetic division to get the factors of this. Okay, so I'm going to choose 3, and it wouldn't matter if I'd chosen negative 7 or 2 or 3. I'm going to get the factorization of this. So I'm going to choose 3. And I'm going to use synthetic division on this. So 1 times 3 is 3, and if I add, I get that. 5 times 3 is 15, and if I add negative 29 and 15, I'll get negative 14, and negative 14 times 3 is negative 42. So this is what I expected. That's my remainder. And those give me the coefficients of the quotient. If I start here, that's my constant term, that's my x coefficient, and that's my x squared coefficient. So I can rewrite this as the divisor. The divisor is x minus the number in the box, times the quotient, which is x squared plus 5x minus 14, plus the remainder, plus 0. And now I can break this down on my own. It starts with x squared, two numbers that multiply together to give me negative 14, but they add up together to give me positive 5. So positive 7 and negative 2. So I've got my factored, I'm on my way to getting my factored form of f of x. The numerator is x minus 3 times x plus 7 times x minus 2. Now what about the denominator? Well, I could put that into my calculator and look for x-intercepts and do synthetic division, but the first step should always be see if there's anything that can factor out. And we can see here, well, they certainly have at least an x in common. As far as the numbers go, they have a 3 in common, so we can factor out a 3x. So when I remove a 3x from here, I'm left with 2x squared. 39 divided by 3 is 13, and I'm left with an x, and negative 21 divided by 3 is negative 7, and the x's cancel. Now, how do we factor that? Well, it's not x squared by itself, so I can't use the easy trick, but here I have 2 times 1. Now what about here? I have negative 7. So what are the products of negative 7? Well, I could have 1 times negative 7. I might just use parentheses. Or I could have negative 1 times 7. or I could have 7 times negative 1, or I could have negative 7 times 1. Now, as soon as I find one that works, I stop. Now, I want the outside plus the inside to equal positive 13. So I look at this. The outside is negative 14 plus the inside. That's going to give me negative 13, and that's not going to work. So that's a no-go. What about this one? The outside is positive 14, and plus the inside does give me positive 13. I found the one that works. I'm done. I don't have to test the others. So what's going to go into my first factor are going to be 2 and negative 1. And what's going to go into my second factor are going to be 1 and 7. Now, what do we mean by that? I'll have 2 times x plus negative 1. And here I'll have 1 times x, I'll just leave that as x, plus 7. So, this can be written as 3x times 2x minus 1 times x plus 7. So I get back to my original problem, and so this can now be factored as 3x times 2x minus 1 times x plus 7. Okay, that's the factored form. Now, for the domain, we do not do any cancellation. No cancellation to get the domain. So for the domain, I look at the denominator, and I can see if x is 0, that will make the denominator 0, and we cannot have that. I also see here, that's an easy one, if x is negative 7, that'll make the entire denominator 0. Also here, I can see if x is a half, that'll make the entire denominator 0. To see that, if you didn't see it straight off, well, you're not allowed to have that equal to 0, so add 1 to both sides and divide both sides by 2. So x is not allowed to be a half. So if x is 0, if x is negative 7, or if x is a half, it'll make the denominator 0, and that's not allowed. So what x values are allowed? Everything except those. That's my domain. Now, what about x-intercepts and vertical asymptotes? You have to consider that after cancellation. And so I can do this cancellation as long as x is not equal to negative 7. Okay. So the lowest form of f of x is going to be x minus 3 times x minus 2 all over 3x times 2x minus 1. So for x-intercepts, we look at lowest form. I can see that the zeros of the numerator are 3 and 2, and so I'll have an x-intercept at 3 and an x-intercept at 2. So I have 2 x-intercepts. And for vertical asymptotes, I look at the lowest form, and I can see that the zeros of the denominator in lowest form are x equals 0 and x equals a half. So I have 2 vertical asymptotes. Their formulas are, they're the vertical lines, x equals 0 and x equals 1/2. And so that answers all the questions we need to know about this. You try and put this into your calculator and look at it. It is not at all obvious that these are what's going on because it's so difficult to see in a standard window, and you really have to know where to enlarge to see actually what's happening. So factoring is the key to getting this, and so I'm going to stop the video there.